Hi everyone. Today we are going to learn about the M1 of mathematics engineering. Okay, let's take the first important topic in a module 1. It's symmetric and skew-symmetric matrix. Okay, let's find the formulas of symmetric matrix and skew-symmetric matrix, where symmetric matrix represent as P, where P equals to half into A plus A transpose. Skew-symmetric represented as Q, where Q equals to half into A minus A transpose. Okay, let's add the example here. Okay, let me take a question. Yeah, A equals to 2 minus 4, 9, 14, 7, 13, 3, 5, 11. Where the transpose of this matrix means the diagonal elements remain same and the non-diagonal elements exchange their positions, like the lower diagonal elements returns in upper diagonal elements place and the upper diagonal elements will be written in the lower diagonal elements place, where here 14, 3, 5, minus 4, 9 and 13. Okay, let's find the symmetric matrix first. Symmetric matrix means, okay, P equals to of A plus A transpose. We need to add both the matrices given, the matrix given here and the transpose we found for the matrix they gave. And I'm writing the sum of both the matrices, but you should not skip those steps because each step carries a particular amount of marks in your examinations. Like the sum you will get is 4, 10, 12, 10, 14, 18, 12, 18 and 22, where you will be having 1 by 2 in a outside of the matrix. You need to solve this, like multiply that 1 by 2 into every element in a matrices, like 4 into 1 by 2, 2 ones are 2 twos are 2 ones are 5s are. Likewise, you need to short it down to 5, 6, 10, 14, 18, 6, sorry, 9, 9, 11, 22. What did it? 5 and 7. This is the symmetric matrix, taken matrix. Same way, we need to find the skew-symmetric matrices, where Q equals to half into A minus A transpose. You need to subtract the both matrices we wrote here. And I'm writing the direct answer as I did before. Like you'll get like equals to 0. Okay, I will write the final answer by multiplying this up into the inside of the matrices too. And the final matrices I will get is 0 minus 9, 3, 9, 0, 4, 3, minus 4, 0. You can find it out. The diagonal elements are 0. The opposite elements of the non-diagonal elements are changed by the symbols. Hence, this is the skew-symmetric matrix of the given element. They might also ask for the, wait, let me differentiate it, and then sum of symmetric and skew-symmetric matrix. They will ask. Then you should need to find both the symmetric and skew-symmetric matrices, and at the end you need to add both the matrices you got, like a P plus Q. Like I'm writing directly, but you guys should write both the matrix of P and matrix of Q, and then write the sum of matrices you will get. It's the end of the topic symmetric and skew-symmetric. Any topic they give, you should first need to find the transpose of that matrix by writing the elements same as same, like you should write the same diagonal elements like a transpose of A matrices and interchange the elements of lower diagonal elements with the upper diagonal elements, and then you need to add both the given matrices and the transfers of that matrices and then multiply with the 1 by 2, then it's no then the matrix you get will be known as the symmetric matrix. And if we subtract both the matrices like the given matrices and the transfers of that given matrices and multiplying that subtracted matrices with 1 by 2, then you will get then you will get one matrices, and that matrix will be known as the skew symmetric matrix. If they ask for a sum in a questions, you should need to add both the symmetric and skew symmetric matrices you got at the end and call that matrix as sum of symmetric and skew symmetric matrices. Okay, let's go to the next topic, orthogonal. Okay, let me tell you what's orthogonal means. Orthogonal means the multiplication or a product of A into transverse of A or transverse of A into A equals to identity matrix. Identity matrix means 1 by 1, 0, 0. This is known as an identity matrix. Okay, there is a most important questions which are going to be repeated in almost of the papers, like is state that A equals to cos theta, sin theta, minus sin theta, and cos theta. Shit. Okay, let's have the transverse of that given matrix is equals to cos theta and cos theta, interchange of the non-diagonal elements, minus the sin theta and sin theta. Okay, let's have the product of both the elements, like A into A transverse equals to, you should multiply the row of one matrix with a column of another matrices, and the next row with first row with the both and next row with the both, which covers every element, and ultimately we'll get a product of that matrices you're going to have the product. So I'm writing the direct next step here, the multiplication steps into transfers. I will write it in terms of cos square plus sin square theta, sorry, and you will get as minus cos theta into sin theta plus cos theta into sin theta. Here also we get the same, like minus sin theta cos theta plus sin theta cos theta. Here we will get cos square theta plus sin square theta. Close of the matrix. And here the both can be cancelled. 0, 0, same. 1 equals to identity matrix. Hence, the given matrices is orthogonal. Sometimes they also ask like to find the variables inside the matrices they are given. They used to add the variables inside the matrix they give, and used to say it's an orthogonal matrix. Find the values of the certain elements, like certain variables they have given inside. Like for example, okay, A equals to 0, 2bc, sorry, A b minus A minus bc. It's an orthogonal matrix. Find the value of A, B, and C. Let's have a look on it. Let's find the transfers of the matrix they have given equals to A, 2b, B minus B, C minus C, and C, and 2. And then we need to have A into A transverse. We will get it like, I'm writing it directly here because of the shortage of the spaces. You need to write this matrix and this matrix, and then I have the product here, like by Multiplying both, you will get 4b square plus c, 2b square minus c square minus 2b square plus c square. Again, next row, 2b square minus c square, a square plus b square plus c square, a square minus b square minus c square. Again, the next row is minus 2b square plus c square, a square minus b square minus c square, and a square plus b square plus c square. Hence, the given matrices is orthogonal. We can take this equals to identity matrix. Like in identity matrix, for the 3 cross 3 matrix, we can take it as 1 0 0 0 1 0 0 0 1. The corresponding elements will be equals to the given values of the identity matrix. You can next go to the solutions. Sorry, next go to find the solutions. You can take any equations like 2b square minus c square equals to 0, a square minus b square minus c square equals to 0. You can take any equations according to your comfortability, where you can take c square equals to 2b square, c equals to root 2b plus or minus. Here, a square equals to b square plus, you can take 2b square equals to 3b square. And next, you can have like where a equals to root 3b. It's plus or minus. The value of a you have got. And you can take the next equations to find the next a variable, 2b square plus c square equals to 1, where 4b square plus 2b square equals to 1, like b equals to plus or minus 1 by root 6. At the end, you can write it like a equals to plus or minus root b, b equals to equals to plus or minus 1 by root 2, b equals to plus or minus 1 by root 6, and c equals to root 2b equals to 1 by root 3.